Welcome to episode 64 of the High Tech Forum podcast. And following a theme we've been developing here over recent weeks, we're going to discuss some more issues to do with spectrum, specifically some of the international global issues that came up in it's now been about a month since the last congressional hearing on spectrum before the one today, which was also interesting, but too early to talk about that quite yet. And we're fortunate to have as a guest Jayne Stancavage from Intel Corporation. Jayne, I'm so happy to have you here. And I'm going to read your bio a little bit. You're the chair. Not only are you the global executive director of product and digital infrastructure policy at Intel. Are you based in Santa Clara or in?
No, California, though.
Oh, okay, yeah. You chair the Federal Communication Commission's WRC 23 Advisory Committee, informal working group for terrestrial services, and we're going to talk about what the WRC is and the significance of meeting number 23 means it's held in 2023. You're a member of the State Department's International Digital Economy and Telecommunications Advisory Committee, Board of Directors in the Open RAN Policy Coalition, a group of people we've spoken with here on the podcast before. You're with the U.S. Telecom Training Institute and a member of the Global Mobile Suppliers Association Spectrum Group Management Team, and you're a mom. And so how do you ever sleep?
That'll be later.
After you stop having fun, right?
Exactly.
Yeah, well, thanks so much for joining us on the podcast. I really appreciated your testimony at the hearing, and I was kind of struck by this is watching part of today's Spectrum hearing. I've discovered this is just the way these things work. That people will give you write your written testimony, you give your 5-minute oral presentation, and then people ask you to address questions that you are addressed in your testimony. As maybe they weren't in the room, but I mean, and some of these are just hard questions, right? Where it takes a certain amount of maybe some repetition to get through all the details on it. And the one question that I noticed 3 people asked you about was about the process for identifying, clearing, and deploying spectrum from transferring spectrum rights from basically old rights holders to new ones. And I guess that's the burning issue, right? Like, how do we get that done, and what are the incentives and disincentives to participate in it? To what extent does sharing play into it? What about the international considerations? So if it's not too painful, could you reprise that one more time for people that didn't get a chance to see that hearing?
Sure. So, and feel free at any point to just ask any clarifications. But basically, first, when we look at it from a technical perspective, and we look at the different bands, the different types of use cases we're trying to accomplish. And that when you look at the band, what incumbent services are in there and what the sharing look like with those incumbent services. They have different characteristics. Some you can do widespread clearing, others you cannot do as much clearing. And so what happens is really very specific to what incumbents are there, what types of services, licensed or unlicensed, make sense, when it's better to do sharing. And then we look at the technologies that you can put in, the technology you're trying to use. So you take those considerations, and then you look at sort of what's going on in the international community. And then when you sort of figure out some potential bands where you can get to economies of scale, then you have to actually see if those bands could be considered within, country X, for instance, United States. And so when you look at the incumbent services, in the past, it was a little easier because it was, there were maybe lower hanging fruit. And now it's a combination of, sort of which spectrum can either be cleared and what are some of the mechanisms. So some are under NTIA because they're used by federal agencies, in which case Congress gets involved. And starts looking at which bands may be under consideration, and TIA does studies. And then there's discussion over whether or not they can be repurposed, or some clearing, some shared use, or in the case of some of the commercial use under the FCC, hats off, they've really done some outstanding work in coming up with what you identified, right? The incentives. So you have incumbent services. Are there ways in broadcast spectrum, satellite spectrum, and the 600 megahertz and 3.5 gigahertz band, respectively? Were there opportunities to sort of use less spectrum and make some of the residual spectrum available for new services such as mobile broadband? And so we had the incentive auctions.
And that's what we
broadcast.
call upgrade and repack. And I know Julie Knapp, who for a long time was the chief technologist at the FCC, that was one of his mantras, is that's how you free up spectrum, is you take an existing application, and the classic examples are where we convert something that's analog based, like broadcast television, into digital, and then that reduces the amount of overall spectrum it takes to accomplish the application, often by a half or less, or more. And then you take the excess spectrum you freed up, and you can auction it off to applicants, or make it available as unlicensed, or put it under a sharing model like CBRS.
Yes, and those are really key, because it's not like there's extra spectrum just sitting around, right?
Right.
And so anything.
Well, there kind of is, in the sense that when you get up into the really super ultra high frequencies, like above 90 gigahertz or so, I mean, we've never really done anything with that spectrum up there, so I guess that's available, but there are kind of reasons why it hasn't been exploited already. I mean, that's kind of the contradiction, is like, if it's a really good band for doing, radio based use cases, somebody's probably already doing it.
Well, I think, part of it, though, we've also seen technology innovation, right? So things that, when I had started my career quite some time ago, would have been, sort of unheard of. We were just talking about the 3.5 gigahertz band. That would have been the equivalent sort of, oh, that's so high, nobody would ever use it. And now we call that midband, part of the midband. And so, yes, as we look, for instance, above 90, there's some research on some of the 6G stuff right now, looking at, not exclusively that, but low, mid, high, and some of the high that they're looking at is in the sub-terahertz, and you are in frequencies where you can get really very, very large channel sizes, which is really important for data rates, but it's over very, very small ranges. So there's only a subset of applications that would fit there.
Well, I mean, it wasn't long ago that the idea of using the microwave or what we call millimeter wave frequencies above, say, 22 gigahertz or so, the idea that you could use that kind of spectrum to support a mobile application was ridiculous. I mean, if you proposed that 10 years ago to a group of radio engineers, they'd laugh you out of the room. But, that turns out to be a really super important component of the ultra-fast 5G systems that the big three carriers are rolling out. Especially, Verizon made a big bet on that. I mean, turns out it's the barrier is just the investment it takes in building lots and lots of little antennas that are pretty close together. But from a technical standpoint, you can certainly do mobility. And it was kind of embarrassing to me to find that out, because I was one of those people that just said, no, that works great for fixed microwave applications, because it's a narrow beam and it does, it behaves a lot like a wire, but won't be good for mobility. But wrong.
Well, I think part of it is we have had opportunities where things that I would never have expected from a policy perspective, somehow the engineers figure out a way, whether it's antennas or, like massive MIMO active antennas, et cetera. There's just so much that has happened that enables that. You still have propagation to deal with, and how far something's going to be able to travel. But internationally, we actually had to do a technical feasibility study to show that there was the possibility of being able to operate in millimeter wave bands, because a lot of people had those questions.
Mm-hmm. Mm-hmm. Well, and it's well, I guess this is kind of common sense to people that work at Intel, but it's all driven by Moore's law, isn't it? I mean, there are things that we couldn't do 20 years ago that we can do easily now because we have the processing power to do digital signal processing and these advanced modulation schemes like massive MIMO. And the impractical becomes practical when you have the tools to make it work.
Yeah, when I think back, so I this is over 2 decades that I've been at Intel, and when I think back from sort of when I started, what semiconductors did from a performance and capability perspective versus now is just incredible. But it's just so broad, right? Like there's so many pieces that Moore's law has now impacted, right? And communications, as you said, is one of them. It is like, how can you come up with the technology that's going to, and have the capabilities to take advantage of, to overcome, in some cases, things like, well, no, we could never do that.
Mm-hmm. Mm-hmm. Yeah, I mean, when a high frequency radio signal strikes a leaf on a tree, it tends to get scattered a little bit. But that just means it bounces off something else, and it kind of a lot of it ends up getting to the right place anyway if you can just correlate it and put it all together.
Well, that's actually like like some of the advantages of
Yeah, yeah.
beamforming. It's just it's incredible. Like you just, even working in the space, it's hard to keep up with everything that's going on. Just it boggles the mind
Mm-hmm.
sometimes what we've accomplished.
Yeah. Um. So
We
yeah,
we
I mean,
being my colleagues, not me.
uh, well, I mean, you don't disregard your own role. Don't without the work that is done by the World Radio Conference, the global market for wireless communication systems wouldn't be nearly as robust as it is, right?
Yes.
And I think that's probably one of the, a lot of this is just kind of we're real insular in America, and we just figure we just do things our own way, and the rest of the world has to catch up. But when you're dealing with things like, well, with say satellites, both geosynchronous and low Earth orbit, and terrestrial radio systems, radar, aviation. I mean, these are global things, and then there's a strong need to develop interoperable standards so that we can develop products in one part of the world that we use in another. And the World Radio Conference is pretty vital to making that happen, isn't it?
Yeah, and I think also just right, like the rules of the road for global spectrum rules, right? So the World Radio Conference updates the international treaty governing the use of radio spectrum, and the U.S. is a very sizable market and is able to generate some economies of scale on its own, which allows for a little more insular look. But as we look for economies of scale, and for many countries, it is absolutely crucial to be able to take
Mm-hmm.
advantage of
Mm-hmm.
economies of
Mm-hmm.
scale, just to have a sizable enough market that somebody provides a solution for you. And so every 4 years, the World Radio Conference is held, and there's a set list of agenda items, and we go through and update the treaty, or in some cases no change after the 4 years of deliberation. The decision is no change, and then the which bands are being used for different applications gets updated, and we go from there. And so it is crucial for many countries, and it's also crucial for when the U.S. talks about leadership, like at the last World Radio Conference, for instance. Many of the millimeter wave bands we were just talking about that the U.S. had opened for 5G, or in the FCC term UMFS applications, those bands were adopted. Many of those bands were also adopted by the World Radio Conference in the international community.
Mm-hmm. Yeah, I'm thinking about even the way companies in that are we think of as U.S. companies do business in this area is international. I mean, in my experience with Intel, a lot of the networking chips were developed in Israel. Uh, the software for them was written in the United States, and the manufacturing was done at a variety of fabs, some in the U.S. and some in places like Malaysia. So, and that's you could say that about pretty much every component in a mobile phone or in a computer these days. It's a part of a global market.
Well, I think the biggest part for the global market is actually, right, like for me, less so during the last couple of years, but I can go anywhere in the world and my phone
Yeah.
works, my laptop works.
Mhm.
And so, to really have the economies of scale, it's one thing if you're an operator buying a base station. It's
Yeah.
another thing if it's a consumer device.
Mhm.
Um, and you travel somewhere else. And in the past, we've used to have to harmonize exactly, the exact megahertz, how to match up because we
Right.
used frequency division duplexing. Now, many of the mid and higher bands, we use time division duplexing, and that allows some slight variations, and still the same economies of scale. But, I never underestimate, I get off a plane somewhere, I turn on my phone or I like boot up my laptop and I connect. Um, I may not speak the language. I may not know where the taxi cab is, but I can connect.
Well, I think this is actually with certainly among the kind of people that we interact with. Certainly a part of the buying decision and who your carrier is going to be, because you evaluate what their service is like domestically, and you also look at what they do to you when you're traveling outside the country. And some of the carriers have been more aggressive in going after that market than others. But it's definitely part of the equation. I mean, when people are mobile, these are mobile devices, and people are mobile. The better it works, everywhere, the better it works. Um, one of the things that one of the things that I've followed is national broadband plans, and so pretty much. Last time I checked, about half the countries in the world had adopted one because they didn't want to just, I guess, kind of haphazardly fall into the future. It's a good way to take some control over it. But an awful lot of them were written really before the advent of the iPhone. And this is one area where in the United States we kind of stand out. And it's just, I think, well, we weren't really eager to have one for a long time. But in the first year of the Obama administration, there was a team created at the FCC under the leadership of Blair Levin, who'd been chief of staff to Chairman Reed Hunt during the Clinton administration, to develop a national broadband plan for the United States for the first time. And because of the timing of that, a big component of that plan was had to do with wireless. And the team identified a phenomenon called the spectrum crunch, where they were looking at the adoption. We were far enough into the iPhone revolution that people could start to look at the growth and demand for radio spectrum. And of course, once you have app stores and this kind of the sky's the limit on the creativity of the people creating apps, you need to have to ensure that you have the spectrum to support the data the apps want to move. And so they identified that we had about 500. We needed to free up about 500 megahertz of spectrum, and the most likely candidate to do that with, of course, every license could be reviewed, but government seemed to be the low hanging fruit there because there are a number of applications in which government was acting as its own network operator. So rather than just sort of buying a service from a commercial provider, which wasn't an option necessarily when some of our public safety and military applications were developed, uh, and that would be a place to look. And I think that's kind of the beginning of the notion of a spectrum pipeline. And it was understood that it would take some time to transition a band that was in use from an old use to a new use. And it just had to be, I mean, they didn't actually explicitly talk about spectrum pipeline the way we do it today. But, you know, you can kind of read the tea leaves there, and like this is a new function of government when licenses are being issued, as long as licenses need to be issued to radio transmitters, there should be a review process, and it should be part of a scheme to recognize that none of these applications are going to last forever, and there probably needs to be some sort of a shelf life and you know, things like that. Well, so how important do you think that is to where we are from a policy perspective today? Is there a general understanding that we need to think about spectrum licenses in a more dynamic sense than maybe we have in the past?
Well, I think, and again, like hats off to Blair and the team that worked on that. It really was, um, very eye-opening, but also it had sort of the audacious goal and then the analysis that backed it up. And to really go out and look, and as you said, some of it was timing, right? To say, hey, we actually want to go out and do this, and to have an understanding of what was going on. We do see this in other countries now, a lot of national spectrum strategies being formed, because if broadband, more robust and universal broadband is the goal. And I think as a result of the pandemic, we really have seen how crucial that is. So if we look at that and say, okay, this is what we're trying to do, and mobile broadband really became like it was at the right time, as you said, sort of in terms of mobile broadband and where we're going with it. And then when you look at that and sort of being able to use that to get service to somebody's house, yes, okay, so we know we need spectrum, and then to go off and do the analysis. Now it's gone a step forward to sort of say, beyond sort of there's a spectrum crunch and we're going to need more and we need to think about it. I think now we're sort of at a point where we continue to see an increase in demand. It is astonishing to me, even working in this space, just how incredible the demand continues to explode, basically. And wider channels for the applications that, as you said, are being developed on top of it, right?
Oh yeah, I
Um,
mean, if it's only 160 megahertz, it's nothing.
it's funny, right? Because I remember 5 megahertz channels are like 1.2, and now it's
Oh yeah,
yeah,
they were. I think back in the Gen 1, it was like even less than that. It was like
yeah,
uh, 1.25.
1.25.
Yeah, yeah.
Yeah. So and now it's like 320, or how what is a reasonable 100 megahertz channel size? But you need that to be able, is like that with the latency and what you're trying to deliver, because it turns out that sending a video image takes more bandwidth than just a voice call with no, just a disembodied voice call. But
Well, and it turns out when you get into the higher frequencies where there are more things that can cause reflections and essentially misdirection of radio signals. One way around that is to make the channels fatter. Uh, and it turns out those two things go together, and it's a almost like a beautiful coincidence, because the newer applications need more bandwidth than the older ones did. And also, well, the newer frequency bands also require more bandwidth to be fully functional. So it kind of, it kind of all works out.
well, yes, and certainly the wider channels, our ultra wide channels, are available in the higher frequency bands, but propagation still exists there as well, right? So you do need some of the other
Mm-hmm.
bands. It's just when you look at some of the widest channels, right? Like you can do, maybe you get 20 here and 100 megahertz channels, the next swath of frequencies. And then as you go up towards some of the higher bands, then you're talking maybe a gig channel in some cases, right? One
Mm-hmm.
gigahertz. So
Yeah.
it's kind of piecing together the different scenarios, and then finding the spectrum that can support it, and then deploying in that spectrum. and getting the devices into the hands of the users. Other than that, it's easy.
Yeah, nothing to it. That's I watching the hearing today. Well, this is true in your hearing last month and this one today. The best congressional, if you want to restore your faith in government and the ability of Congress to like work together productively, what you should do is just watch Spectrum hearings and don't watch anything else. But I mean, there was so much comedy at the committee at today's hearing that it was like a throwback to the good old days when members of Congress and the president from opposing parties would get together for cocktails in the evening. The one of the things that came up, Anna Gomez, who is now she's working, I guess, at Wiley Ryan. She's a vet of the NTIA and FCC, and as lawyers go, I think she has some of the best understanding of spectrum that anybody does. She was saying that we need to have a national spectrum plan, and which I guess would be. She didn't elaborate on what that means, but I take it that it's something like the national broadband plan, only more focused on radios, and she seemed to be met with some agreement on it. I think other people are it's like a new idea. So in Washington, D.C., you kind of have to wait till new ideas are widely circulated, really, before you want to take a position on them. But as a general concept, does that make sense to you?
Yeah, and I think I do think it makes sense. And I do think that, right, like it is very important part of the national broadband type of plan, right? Because broadband you can do over wire, fiber, and wireless, and right, and all of the different technologies will play together and sort of create the uniform, like you need all of you need more than one technology. You need multiple forms to actually
Mm-hmm.
cover to provide the coverage, and also just to make sure a choice of options for the users. But for the wireless ones, I have yet to meet a wireless technology that doesn't need some spectrum, right? Like that's why they're wireless. And so if you're going to do
Yeah,
that,
yeah.
you
Well,
need to have
infrared.
spectrum.
Yeah, infrared.
Yeah.
That's spectrum too, though.
Yeah. Okay,
Yeah.
that's a fair point. But
Yeah.
the the piece, when I look now and as I look toward the future, I do think it's really critical for the US to be thinking about this. Other countries as well, but like just looking at it from the US perspective, it's really important for the US to be thinking, okay, what are the possibilities? Because you usually need multiple options for each one
Yeah.
that actually
Yeah.
gets selected. And then even out of that, you're going to need multiple bands made available. And so having that discussion, progressing studies and moving toward, okay, well, what can we actually use in the future is going to be really important, sort of in the near term, well, especially midterm and longer term, because these things take time. And
Mm-hmm.
it is really important that we start progressing some of those discussions. So, and Anna is a very good lawyer, yes, and she understands the spectrum stuff. I agree with that as well, Richard.
Yeah. She's got a good sense of humor too. Um, so yeah, we were in the rehearsal. We talked a bit about the. That's an inside joke, folks. That's what it is when you forget to press record on Zoom. That's the rehearsal. um,
It's another opportunity for us to talk, Richard.
yeah, absolutely. I'm enjoying it. So, yeah, we have flexibility is important, but standard to me, it's kind of like the stand. You need international standards to develop hardware too.
Yes.
And once you've got hardware that can work, that has enough tunability and configurability that the software can adapt it to different uh, variations. Um, then you've got this kind of ideal product platform that you can take all over the world, and it'll work with the best stuff that's available. Uh, and that so the software is kind of the magic that makes it happen. But then in the regulatory realm, it seems like we're proceeding down a path where we're still testing the applicability of the different licensing models with the the strictly licensed, the unlicensed, and then this kind of hybrid CBRS where it's kind of licensed, but kind of not because there's a priority, priority rights holder. Um, do things like CBRS really have much of an impact on the way chip manufacturers produce product, or is it just an opportunity that you either decide to pick up on or leave to others?
Well, I think part of it is always going to be how, when we look at something, we look at it, as I was saying at the beginning, right? Like, what are the opportunities? Can it be available for cleared exclusive use? Does it make more sense in this case for the sharing environment and where the band is for it to be on license use? And in some cases, when you look at shared spectrum, sometimes it's exclusion zones, sometimes it's trying to be more time based, et cetera. And when you look at these models, I think and this is not specific to CBRS, but just in general for some of the shared access, you know, if you have an opportunity to put spectrum to use versus have it lie fallow, some use of the spectrum,
Oh, that's
some
true.
additional use is always good, right? Like,
Yeah.
so somebody's using it, if you can get something more out of it, great. But when you do that, it's really important to also then, what are sort of the least restrictive technical conditions. Like, that's actually a term they use in Europe, right?
Hmm.
What are
Hmm.
the least restrictive technical conditions that you would need to put in for the technology? And then when you have sharing mechanisms, right? What is the simplest one you can do? Because if you have more restrictive conditions or a more complicated sharing mechanism, it does make it harder to use the band. So, yes, it's great to move spectrum from fallow or fallow for commercial use to something that's used, but there's still these other things that need to be taken into account. And I think, in some cases we should also be looking and sort of saying, hey, is this a band that maybe internationally is more one way versus another, license, unlicensed, et cetera, just so we're taking that into account when we're thinking about what may be used for the band. Because, for instance, the CBRS band is one that is heavily used for exclusive license in some of the other countries, right? So that means
Hmm.
there's already going to be some economies of scale there. So it is just in general, when we looked at shared, it's sort of that least restrictive condition and simplest sharing mechanisms, I think, are some key points to always think about.
Yeah, I'm always kind of confused about the way we use the word shared when we talk about spectrum licensing. Because when a company like Verizon or AT&T buys a spectrum license, they don't do it just to use it among themselves. I mean, it's the public is using it, and those of us who are subscribers, to the services those companies offer, we're sharing with each other. And to me, that's an extremely simple sharing model because there's one kind of master point of control that every device hooks up to, and then all the other control points in the network all communicate with each other, and they could do that simply because it's just they're all trusted within the network and have interoperable technologies and all that sort of thing. But I guess it's just kind of how you rate the mechanism because Wi-Fi is completely an uncoordinated system, but it's very simple too. I mean, its own way. It's could hardly be simpler. You just listen for radio traffic in your area, and if you don't hear any, then you can go ahead and use it. Go ahead and send out a packet or an aggregate of packets, as it may be.
Kind of like
Um,
conversation at the dinner table, right?
yeah, it's not exactly a new idea, and well, that was what the transmission model for or access control model for Ethernet was when it started. But even that, it was actually based on a radio network, based on Aloha, which was an academic radio network that spanned some of the outer islands in Hawaii. Uh, and it was just by necessity anyway. So um, I'm having a hard time keeping my earpieces in today. So what do you see as the most exciting prospects for the wireless future?
I whenever anybody asks a future prediction, I have to give my standard caveat of I'm not very good at predicting the future, just because I'm always stunned by
Mm-hmm.
where things go, right? Because the way I look at it, right, like we just described like this long process, and you brought in the standardization piece as well, right? But from sort of going from an idea to actually having the end user device with the technology that somebody can utilize. And then we have a whole nother ecosystem of technology developers who come up with some incredible applications that sit on top of it. If you had told me, 5 or 10 years ago that I'd be using, my phone or my computer to do some of the things I use them for on a daily basis, I would have been stunned. So um, with the caveat that I can't predict the future, I guess I'll go with the one thing I'm certain of is not the ones I would have ever expected,
Mm-hmm.
but that there would be incredible uptake. Um, that in hindsight, I'll sit there and say, "Oh, but of course that makes so much sense," but not early enough to guess now, right? But
Mm-hmm.
you sort of sit there and you stop and you're like, "Oh, that makes so much sense," or like, "Why didn't I think of that?" It's improved my life, but uh, so my prediction is wireless will continue to just explode in terms of growth and the applications that run on top of it. I will never guess the right ones, but the demand will be bigger than anything I had envisioned.
I saw a really intriguing kind of a clickbait headline today in the news where the CEO of Nokia said 6G will be here by 2030, but we won't use it on smartphones. And of course, you got to read that article. But what he's saying is that by 2030, smartphones will have given way to smart glasses and wearables. And so, I mean, you're probably going to have a device like a smartphone, but it won't necessarily look like the smartphones of today, too. So it's like both the networks will be better and faster, more capable, and that's going to spawn a generation of technology that's better, faster, and more capable, and kind of more seamlessly fits into life. So I mean, I guess a lot of people, they don't mind like carrying their cell phone around with them, but to me, it's kind of it's a nuisance. So I'm really
But
happy to have a smart watch, so I don't have to think about where my cell phone is. Right, I get a phone call, the watch tells me, and I can actually do like Dick Tracy and talk to people through my watch. I think that's cool.
well, I think the other piece of that, and I did not read the headline, so I didn't. But the other piece I think is just like all of these applications sit on your phone or your laptop now that we did, or at least I did not envision. Those are still what I refer to as sort of human centric, right? It's
Mm-hmm.
me, or it's any one of my, any person. With 5G and increasingly, like as we move towards like 6G or Wi-Fi 7, et cetera, the what is happening from a technology perspective in terms of when you get down to some of the latency, the ultra reliable low latency, or if you get to the massive machine type, it enables a lot of different industries to utilize it.
Mm-hmm.
And so the applications that have been developed on for humans, we now have the ability for technology developers to come up with those applications for different industries. And so then it's not that it's, whether it's a smart glasses or smart watch, right? But it's, what is it for detecting welds on a factory floor, or what is it for, host healthcare, et cetera, whatever the application is, where it's not around a human, but enabling those advances in some of the different businesses. And then it has even wider spread impact on the economy, right? Because it's not what it means for an individual, but whole sections of the economy.
Yeah, you brought that Welds example up in the hearing. I thought
Yeah,
that
it's
was really great. And it is true that one of the use cases for 5G that was anticipated before the standards were developed was automation, uh, robotics, really. I mean, so IoT,
Mhm.
and so the people sometimes they well, what do we need 5G for? Because you just make 4G faster, and that's really all I need. But I guess that's kind of like the old Henry Ford thing of if he'd asked customers what they wanted, it would have been a faster horse.
Yes, and then, well,
Uh,
exactly, right, and it's just, it's more than just data rate, and I don't know that, those, it it's more than that, but I think we have to see those capabilities to start really putting some of the technology applications running on top of it.
well, and to do the weld examination example, you need to have you need to have a very high resolution camera, probably more than one. You need to because you
Mhm.
need to look at it from different perspectives, and it's not just the visual impression it makes. It's also you can kind of X-ray it, right?
Mhm.
Find internal defects, and then but that's a massive amount of data, and it's hard to massage that data at the point of capture. So you capture it with some, very sophisticated high resolution cameras, ship it off somewhere where a massive array of plugged in processors look at it and then they go, oh, yeah, that's a bad weld. You need to redo it. You break that example down and there's really, we unpack it and there's so much there that,
Yes. Yeah,
yeah, that's
instead of
great.
instead of pulling one car a day off and sort of sampling, to inspect every weld on every car coming through. And yes, the compute, right? So you have the device taking the picture, taking the image, and then you have, mobile edge, you have compute nearby to actually be able to process that. Then you have artificial intelligence being able to like determine, okay, is this a good weld or not? Because it's not a human who's looking at every,
Hmm.
the millions of welds. But then being able to say, hey, these are all fine, or pull that car. So before it goes through the whole process, you pull that car and you make sure that the weld is done correctly. So it's absolutely, a combination of so many different technologies coming together, but it's a real world application, and one that has benefits, that frankly, one of those in the category of I would not have imagined it a few years ago, right?
Well, this is the intersection of spectrum and the compute power that we get from Moore's law
Mhm.
advances in semiconductors. And as long as we're on that trajectory, seems to be like I think maybe Moore's law was sort of a conspiracy that was invented to sell spectrum rights.
No,
I'm
I
just
think it was,
I'm kidding.
if it's just, it's spread more widespread than I would have ever envisioned, but just a very smart guy, right? Very smart guy who happened to make the right prediction.
Well, I was
Captured the
I,
data in a way that made sense.
I was reading today that when they formed the company Intel, the first name that came to them was More Noise.
Oh, see, maybe it was about spectrum.
Yeah, yeah, yeah. But then said, no, but we don't want the noise. We want the signal. So they
Yes.
went Intel. Well, how did we get the signal? What's the intelligence?
Well, that's what
Well,
Andy Grove brought to it. He was the one who pulled the interference out, right? So no,
uh,
it's a long, proud history going all the way back to Gordon Moore and Robert Noyce and Andy Grove. So it's
Grove was the one that said only the paranoid survive, right?
correct.
Yeah, truer words have never been spoken. Okay, folks. I appreciate the time you spent with us, Jayne, and really enjoyed the conversation. I think it was the right balance of enjoyable and informative. So that's what we try to strike here. And folks, High Tech Forum podcast we are something that we do at least once a month and sometimes more frequently. So wherever you heard this, please subscribe and give us some feedback. And you can get notified when when new podcasts come out. So once again, our guest today was Jayne Stancavage of Intel, and I'm Richard Bennett signing off.